Here's the homework problem that was assigned. Determine the percent yield of precipitate if 25.00 grams each of aqueous rubidium carbonate and calcium chloride are mixed together and 10.00 grams of precipitate is recovered. So we have two reactants listed here and one product listed here. In order to determine how much of the product is recovered, or what the percent yield of the product recovered is, we first have to figure out which one of the two reactants we calculate with. So we have to figure out what is called a limiting reactant. We have two reactants. We have to figure out which one of them is the limiting reactant, because by definition, when the limiting reactant runs out, the reaction stops. When the reaction stops, we don't make any more product, and so we have to calculate percent yield from the theoretical yield, and the theoretical yield has to start with the limiting reactant. So let's lay out the equation here that describes the problem. Remember, a chemical equation is a symbolic representation of a chemical reaction. So we've got aqueous rubidium carbonate. Rb is rubidium. Carbonate is CO3 with a 2 negative charge. Rubidium has a 1 plus charge, so we need 2 rubidiums to balance or charge balance this formula. This is aqueous. It says so in your solubility rules. It also says that group 1 metal salts, like this is a group 1 metal. Rubidium is in group 1 or column 1 of the periodic table. Those are always soluble, so in water it's aqueous. And we're going to have another another reactant here, calcium chloride. And it's aqueous, it says. It's also true that chlorides are mostly soluble, and then there's no exception for calcium, so by definition this should be aqueous as well. And so we're going to have two products, and one of those products needs to be a solid, because in an aqueous environment, a precipitate is a solid. And so when we figure out what the reactants, or the products rather, are going to form from these reactants, this is a double replacement reaction. Two ionic compounds. This is ionic because it has a carbonate or polyatomic ion. This is an ionic compound because it is made of a metal and a nonmetal. And so when I have two ionic compounds like this, we have a double replacement reaction where the front part of this goes with the back part of this compound. So we get rubidium chloride. Rubidium has a 1 plus charge, chloride a 1 negative, so that's balanced. And group 1 metal salts are aqueous or are soluble, and therefore aqueous in a water environment where there's water around. And so the other thing that we're going to make is calcium and carbonate. And carbonates are mostly insoluble, and there's no exception for the insolubility of a carbonate compound when carbonate is combined with calcium. So this is our solid here. Okay, so we've got to figure out, we've got 25 grams rather of this and 25 grams of this. Which one of those do we start our calculations for or with to get to the theoretical yield of this product over here? Which one of these two do we start with? We need to start with the one that runs out first, the one that stops the reaction moving, and that's the limiting reactant. So we first have to figure out what the limiting reactant is. Okay, and so we got to calculate, do a mass-to-mass stoichiometric calculation from one of these two reactants to the other, and use that amount we calculate to determine what the limiting reactant is. So I'm going to start with the rubidium carbonate. It doesn't matter. You could start with calcium chloride and you would get the same result. But first we have to balance the equation. We've got rubidium here and carbon and oxygen. Rubidium and carbon and oxygen and calcium and chlorine. We need a kind of a grid here to do an atom inventory and balance the equation. And so I'm going to start with 2 rubidiums and 1 carbon and 3 oxygens and 1 calcium and 2 chlorines. And over on the other side of the equation, I've got 1 rubidium and I've got 1 carbon, 3 oxygens. Let's see, I've got 1 calcium and I've got 1 chlorine. And so if I put a coefficient of 2 here, that's going to change the number of rubidiums and the number of chlorines here, and we'll end up with a balanced set of atoms, and that means our equation is now balanced. So with a balanced equation, now we can go on and do our stoichiometry. So we start with either 25 grams of this or 25 grams of this, doesn't matter. I'm going to start with 25 grams of this just because it's the first thing I wrote down. I'll put the starting amount over 1. And now I need to convert this starting amount into moles. I've got it in grams. I need to convert it to moles. And to convert it from grams to mole, grams is a measurement of mass. To convert from mass to moles, I've got to have a molar mass. So we're going to add up all the atomic masses of all the atoms in the formula and find out how many grams that we're going to list that answer in grams, and that'll equal to a mole of this compound. So it works like this. Rubidium, carbon, oxygen. The atomic mass of rubidium, you look it up on the periodic table, you find out it's 85.47, and we have 2 of those. And we multiply those 2 together, we get a sum of 170.94. And carbon's atomic mass is 12.01. And I have 1 of those in the formula, so that's 12.01. And oxygen is 16.00. And I have 3 of those. And you multiply that times 3, you get a sum of 48.00. I know when you multiply, you don't call it a sum, but it's like adding this together 3 times. And we're looking for the sum of all the atomic masses of all the atoms in the formula. So multiplication is just another form of addition. It's like adding many times, okay, especially when you have whole numbers like this. And so we add those together, we get 230.95 grams of rubidium carbonate, and that equals 1 mole of rubidium carbonate. Okay, so that's the molar mass. This is the molar mass here, and it equals 1 mole. And I write it like that in an equality statement form so that I can write a conversion unit up here. I want to put the grams here on the bottom of this fraction because I have grams on the top of this first fraction. Well, it's a fraction if you put it over 1. So we're going to put 230.95 grams of rubidium carbonate on the bottom and 1 mole of rubidium carbonate on the top. And so when I put 2 things that are equal in a fraction like this, this fraction equals 1. That's a conversion unit. Unit meaning 1 thing, or in this case, kind of like 1 thing. All right, so now we need the molar ratio step. We go back to the equation, and since we're trying to find the limiting reactant, we've got to go from one reactant to another reactant. And so this is the reactant I started with here. I need to calculate my way to this second reactant. And so I'm going to look at the coefficients in front of these, and those are going to be moles of these 2 things. Okay, so this is 1 mole of this and 1 mole of this, 2 moles of that, 1 mole of that. But we just need these 2 right now. 1 mole of rubidium carbonate goes on the bottom because I want to match the units and species here. And then 1 mole of this is going to go on the top. Okay, and I need to start canceling units and canceling species. So units, species. And now that I have this in moles, I've got to convert it to grams. And to go over here, we went from grams to moles by putting using molar mass to build a conversion unit. We're going to do the same thing here, only the conversion unit is going to be sort of flipped from the form we did here. But we've got to calculate the molar mass for calcium chloride. So calcium's atomic mass from the periodic table is 40.08. We've only got 1 in the formula. Chlorine's atomic mass is 35.45. And we have 2 of those. And we multiply those together, we get 70.90. Add those together, we get 110.98 grams of calcium chloride, and that's equal to 1 mole of calcium chloride. So I want to match the units and species I have here with what I put on the bottom there. And so this is the part of the equality statement I put on the bottom here. 1 mole goes on the bottom. And then the 110.98 grams goes on the top. Okay. And I can cancel units of moles here and here. And calcium chloride, the species, gets canceled here. And now I'm ready to do the math. I multiply this times this. I don't have to multiply with the ones because they just give me the same answer. This times this hit enter or equals in the calculator, then hit the divide button and put in this and hit enter or equals. And when I do that, I get 12.0134282, and that's grams of calcium chloride. Then I need to round that off to the correct number of significant digits, and looking at the measured and now calculated numbers in the problem, we look at the one with the least digits. That's this one here, 4 digits. So we want 4 digits in our final answer over here. Underline everything after the first 4 digits then. Draw an arrow to show we're rounding off. And we get 12.01 grams of calcium chloride. Now then, we actually had in the problem 25 grams of calcium chloride. Okay? So we actually have far more calcium chloride than we're going to be using up. This number here, this amount, is the amount of calcium chloride used up when reacted with 25 grams of rubidium carbonate. And since this number is smaller than the amount we actually have, that makes calcium chloride the excess reactant, because only 12.01 grams are going to be used up, leaving roughly 13 grams left over. That's in excess. We've got more than we need. And so this is our excess reactant. If this is the excess reactant, calcium chloride is the excess reactant, then rubidium carbonate must be our limiting reactant. And so now that we've identified what the limiting reactant is, this number has no more value to us. This number is only valuable to us in determining which of the chemical species of reactants is the limiting reactant. And since this is the excess reactant, this is the limiting reactant. Since we now know this is the limiting reactant, we can now start the calculation to the amount of product, this calcium carbonate solid here we're looking for, how much product we're looking for. So we start the next part of our problem with this amount, the given amount. Always you start with the given amount of the limiting reactant. Given amount of limiting, remember that. Given amount. It's got to be the given amount. 25.00 grams of rubidium carbonate over 1. And the conversion unit we've already got here. We're lucky here because we started with rubidium carbonate. It's already here to convert the moles. It's already done for us. And then we can cancel the grams, and we can cancel the rubidium carbonate, and we go back to our equation and look for the coefficients in front of the two species we're interested in now. We're now interested in this because it's our limiting reactant. We've identified this as our limiting reactant, and this is our excess reactant here. We're going to start with this and end up with this because this is the product we're looking for. So now our molar ratio changes a bit. We're still going to have 1 mole of rubidium carbonate on the bottom down here. But now we're going to go to this on the top. And there's still a coefficient of 1 here. So we're going to have 1 mole of calcium carbonate. Now the coefficients are not always 1 and 1 here in this molar ratio step. You have to choose the coefficients in the balanced equation to put in this fraction here. Okay? Let's cancel our units and cancel the species. And now we're ready to calculate the amount of product. So we've got to have a molar mass calculation for calcium carbonate now. Calcium has an atomic mass of 40.08, we said, 40.08. And we've got one of those. So that's 40.08. And then we've got carbon, which is 12.01, has an atomic mass of 12.01 from the periodic table. And we have 1 carbon there, so that's also 12.01. And then we have 3 oxygens. And the oxygen's atomic mass is 16.00 times 3, and that's 48.00. And add all those together. And we get 100.09. And since there's no empty slots over here to the right, when we're adding these up, we don't have to round off. This is grams of calcium carbonate. equals 1 mole of calcium carbonate. And so we're going to build a conversion unit to go here. Cancel out units and species. Do the math. And we're going to get 10.83459623. And that's grams, because that's what we have left, grams of calcium carbonate. And we need to have 4 significant digits. Of the measured and calculated numbers, this one has 4, this one has 5, this one has 5. The ones don't count, those are counting numbers. And so we got 1, 2, 3, 4 significant digits in our final answer. Underline everything else. And we get 10.83 grams of calcium carbonate. So this is a product. Okay, here's the product we're looking for, calcium carbonate. We found out that starting with the limiting reactant here, the given amount, given in the problem, 25 grams of rubidium carbonate, we calculated our way to the theoretical yield of 10.83 grams of calcium carbonate. That's a theoretical yield. Just put TY here for theoretical yield, okay? Now then, to find the percent yield, and that's what our problem's asking for, determine the percent yield, we're going to take the actual yield, and the actual yield is the actual amount collected. That's this amount here, 10 grams of precipitate. The precipitate is this calcium carbonate. We actually collected this. This is a theoretical yield. This amount here is an amount that we could get if we could get every possible tiny little molecule or formula unit or ion of all this stuff out. We can't really do that. That's why we don't ever have 100% theoretical 100% yield. It's always something less than that. This is still pretty good. 10 out of this amount is pretty good. So we're going to take our 10.00 grams of calcium carbonate, which is the actual yield. We're going to put that over and divide by the theoretical yield, 10.83 grams of calcium carbonate. Okay? And then we're going to take that fraction after we do the math and multiply that times 100 to get a percent yield. Now, in percent yields, units of measurement are going to cancel. In any percent, the units of measurement should cancel. But in a percent yield, the species also cancel. We're going to have a unitless and speciesless answer, although that doesn't really make sense. We're going to put the species back in there. I'll show you how that works. And so we're going to take 10.00 and divide it by 10.83 and hit enter or equals on the calculator. Then multiply the answer by 100. And we get a very high percentage of 92.336, 103.42% yield. But we need to round off. We've got 4 digits here and 4 digits here, so we need 4 digits in our final answer. This is an absolute number, so we don't consider that 100 there. We could say 100.00000 because this is absolute. Its value is absolute. So we've got 4 digits here, underline everything else, draw an arrow to show a rounding off, and so now we get a 92.34% yield. But we need to say what that yield is. So that's what I'm meaning what I meant a while ago when I said that we cancel out the species, and so it's speciesless, but we need to define what the percent yield is. And the percent yield is yield in this calcium carbonate. So we're going to say in calcium carbonate. And that's how we clearly define what we're talking about. That everybody knows, that I know, and you know what the percent yield is for, which species we're talking about.